Automatic night light. We usually have a light or bulb that illuminates the entrance to our home, yard or garden. Being a lighting outside the house who has not forgot to turn it off. We left it turned on for hours and hours a day and sometimes for weeks, causing unnecessary power consumption and sometimes exaggerated. Thinking about a solution to this problem, we designed an electronic device that handles the power on of a light bulb. When the sun goes down and automatically shuts it off when the sun returns to appear at dawn, like lightning lapse lightning. This circuit operates with voltage from 115 to 220 volts, no need to make any changes. You can light a bulb up to 100 watts. If you want more power lighting devices, you should only change the BT136 triac for one that supports more amps as BTA08-600, which supports up to 8 amps. Operation. The 2.2 microfarads capacitor is in series with the voltage input from the public network, restricts the flow of current, passes only about 60 milliamps or so. The 330K resistor is in parallel with this capacitor. It is responsible for discharge the capacitor when the circuit is disconnected, preventing the condenser stay charged and could send an electric shock when handling the circuit. In the other input of the public, there is a 10 ohm resistor, which works as a fuse and also helps to limit the current. After the current passes through the condenser and the resistance reaches a diode bridge, which is responsible for separating the positive and the negative half cycles and then be rectified by a capacitor, converting alternating current into direct current. Now that we have rectified the voltage with minimal current, we must lower the voltage to about 10 volts DC. We use a Zener diode for this purpose. The 47K is the Zener bias resistor. It needs to be 5 watts since the effort made to lower the current relatively high heat generated. The 10K resistor, which is going to ground in parallel with the Zener diode, helps to support the load. The capacitor of 47 microfarads and 0.1 microfarad ceramic capacitor rectified current again, preventing twisting. Now comes the circuit which handles the automatic on when detecting darkness and turns off when detecting light. The rheostat RB1 is part of a voltage divider with a photoresistor. This gives the possibility to escalate the sensitivity of the circuit. When current passes through the resistor and reaches the center point between the resistor and the LDR. By the time the LDR receives light, its impedance low at 0 ohms, negatively basing the transistor base. But when the environment is dark, the LDR increases to a very high impedance, restricting the passage of current. At that time, positively polarize the base of transistor to N3904. It's in this moment when the transistor collector emitter, negatively basing the transistor base, is polarity to N2907 PNP. This means that leads to their base when a negative voltage soar. When driving the 2N2907, transistor passes a positive voltage from collector to emitter and reaches the optocoupler. The LED lining is in its interior, triggering the phototriac, which is between 4 and 6 feet of the optocoupler. The phototriac lets among pins 4 and 6 by sending a current to the gate of triac BT136. The triac conducts current public network between its terminals T1 and T2 and as the bulb is in series, this goes on. When the resistance returns to receive light, its impedance is low and negatively based to N3904 transistor base. Since the transistor is NPN, non-conductive, and therefore not other transistor, the octocoupler and triac not let logically and off the bulb. In the PDF file, you can download the last item of this project. We have provided the breadboard assembly diagram. Thinking in students who wish to practice and make their own variations of the circuit. Hope it's useful for everyone. Success!